Assalamualaikum dan salam sejahtera saya ucapkan kepada pensyarah yang dihormati Profesor Madya Dr. Muhammad Syukri bin Zainal Abidin dan rakan-rakan daripada kumpulan 11. Pembentangan pada hari ini adalah merujuk kepada tugasan yang telah diberikan kepada kumpulan 11 berkaitan dengan eksperimen 2 Building a Virtual Instrument. Sebelum memulakan pembentangan, ingin saya memperkenalkan diri saya. Saya Nazri bin Rosman, nombor matrik SX210494 EEHS04. Okey, saya serahkan kepada rakan kumpulan saya seterusnya untuk memperkenalkan diri.
Hi, my name is Pravin Raj from Group 11.
Okay, Assalamualaikum dan selamat petang. Nama saya Muhammad Amir bin Zani, nombor matrik SX210481 EEH S04. Dan terima kasih. Serahkan semula kepada Encik Nazri.
Okey, terima kasih saudara Amir. Untuk eksperimen 2 atau assignment 2 yang ditugaskan kepada kumpulan 11, objektif assignment ini adalah untuk to learn the basic of building a virtual instrument, to learn how to analyze and save a signal using virtual instrument. Okey, saya serahkan kepada Mr. Pravin Raj.
Thank you, Mr. Nazri. Okay, if you can see my screen here, we already completed the assignment 2 with all the objects already inserted according to assignment 2. So for a brief, I'll show you how we can create a project from NI Lab virtual. So we just have to click here, click new, and it will redirect us to a new portal, which then you must select generate and display. So for this, I'm not going to do this because we already finished building the project. So I'm just going to show you how we can obtain all these objects from the NI Lab instrument. So this is what we call generate and display, which is a front panel, and this is a block diagram where we will insert all our objects for this virtual experiment. Okay, for this you must go to view and select the function palette. Here you can see it will show you various of objects for different functions. So as this is a simple experiment, so we are just going to simulate a sawtooth signal. Okay, so as you can see, everything is wired complete. This is a knob for scale adjustment. Going to the amplitude, which will be set here. Okay, before we can set anything, we just have to stop anything that is running. Then we can program the object. So when I click into the properties, we can change the signal type here. They give us a variety of signals, which is sine, square, triangle, sawtooth. And the amplitude is set over here. Here's the frequency, phase angle, and all the timings for the relative signal that we are going to test. Okay, and this is a scaling formula object. For this same, we just have to click properties so that we can insert the scaling value. So this is scale to 10. Okay, all these objects are obtained from the function palette, as I showed you just now. This is a knob for adjustment. This is where we are going to stimulate the signal. This is where we are going to scale the signal, and this is a probe to split the sine wave, the original sine wave and the scale sine wave. As you can see here from the front panel, there are two lines. The line with the white line represents the scaled wave, and the red line represents the original wave. And this is here to save the data from the file. So in order all this to work, we need to wire, where you can see I will show you. Okay, just have to bring it to the desired place and let it over there. So it will connect. Okay, so I'll run the function for you so that you can see yourself. And I'm also going to change it to sine wave so that we can have a brief idea on how this whole Labview works. So for sawtooth, so as you can see, when I adjust the knob, the value on the amplitude side changes according to the scale that we set. So now 10, just now, as you see, I set it to 10 times larger. So the amplitude is 1, so 100. That's all. So we can sense the signal here now. So I'm just going to change it to sine. I'm going to set the amplitude to 2. Also, I'm going to do it over here. I'm going to change it to sine, but 4 times smaller this time. So the green here shows that there's no error. So I'm just going to run. See, it changes to the sine wave, and we can adjust everything on the front panel to our desired design. So this is where we change the color, line style. This is for the bar plot. This one, the X scale and Y scale. And we can even export the data to Excel file. So I'll show you how. Just click the export data. Okay. We can obtain data from the experiment and convert it, export it to a data file. That's all from me. So I'm calling Mr. Ame to continue the presentation. Thank you.
Terima kasih kepada Mr. Praviraj. Seterusnya kita boleh lihat melalui software Labview ini ada beberapa kelebihan dan juga kekurangan. Secara umumnya Labview berupaya untuk dibentuk dengan pelbagai fungsi simulasi pelbagai fungsi tanpa memerlukan instrumen secara fizikal yang mungkin memakan kos yang agak tinggi. Konsep penggunaan Labview ini adalah lebih ringkas dan memenuhi penggunaan asas bagi kategori pelajar dan juga industri. Penggunaan Labview ini mampu dikawal secara maya berbanding dengan instrumen fizikal. Antara kekurangan software Labview yang kami kenal pasti, software Labview ini memerlukan kos yang agak tinggi bagi memiliki versi yang penuh dan hanya diedarkan oleh National Instrument, which is NI. Pengguna perlu memahami konsep asas terlebih dahulu jika ingin menggunakan software tersebut secara advance yang mungkin akan memakan masa di peringkat latihan dan juga anti-bug, which is penyah perpijatan adalah lebih rumit berbanding dengan programming language yang berasaskan teks. Setakat itu saja pembentangan kita pada hari ini. Saya serahkan semula kepada saudara Nazri. Dipersilakan.
Okay, terima kasih saya ucapkan kepada saudara Amir. Okay, bagi mengakhiri pembentangan kumpulan 11, saya dengan ini mengucapkan ribuan terima kasih kepada pensyarah dan rakan-rakan daripada kumpulan 11 sepanjang menyiapkan tugasan kedua ini. Sekian, terima kasih.
Terima kasih, Doktor.
Terima kasih, Doktor.
Thank you, Doctor.